GNSS. Say that 5 times fast. But don't let its mouthful of letters fool you. Global Navigation Satellite System is one of the most powerful communication systems in the world, and it's more powerful than any other system, period. You see, GNSS is more than just GPS. It's a constellation of satellites orbiting the Earth that transmit positioning signals anywhere on the planet. These signals can be used to determine precise locations down to the billionths of a second, enabling all sorts of tracking, navigation, and surveying applications. From helping pilots land planes to guiding tractors through fields to soldiers on the march to your smartphone whenever you need directions or your food delivery app, keeping tabs on your order to supply chain managers, tracking shipments, GNSS touches almost every aspect of our modern lives. There are 4 key reasons why GNSS is so powerful. First, it's accurate. We're talking less than a meter in some cases. Second, it's global. You can use it pretty much anywhere on Earth, even over oceans and remote wilderness areas. Third, it's real-time. You get information immediately without any significant delay. Fourth, it's cost-efficient. The initial investment in building the infrastructure can be high, but once it's up and running, it's relatively cheap to use. In this video, we'll explore what makes GNSS so powerful, the amazing things scientists are developing to make it even better, and what to watch for next. First, though, let's talk about what GNSS actually is and how it works. If you live in the United States, you probably know GNSS as GPS, which stands for Global Positioning System. That's the one run by the U.S. military and made famous by TomTom and Garmin. But there are 3 other major GNSS systems out there: Europe's Galileo, Russia's GLONASS, and China's Beidou. In fact, the official name for the American system is officially the North American Regional Navigation Satellite System. But when people say GPS, they really mean the constellation of 31 American satellites run by the U.S. government. Together, these 4 constellations make up GNSS. Here's how they work. Each GNSS satellite orbits about 20,000 kilometers above the Earth at speeds of around 14,000 kilometers per hour. As each satellite passes over you, it sends out a signal containing the precise time that the signal was sent. Your GNSS receiver, whether it's in a smartphone, a survey instrument, or anything else, listens to multiple satellites and calculates how long it took for each signal to arrive. Because the speed of light is constant, it knows exactly how far away each satellite is. Using some basic trigonometry, it then figures out what your coordinates are. So what's so great about GNSS? Well, for starters, it's incredibly accurate. Modern GNSS receivers can pin down your location down to the billionths of a second. There are also various techniques like differential GNSS that can correct for minor variations between the actual and calculated positions, improving the accuracy even further. That level of precision has revolutionized everything from farming to shipping to aviation. Farmers can map their fields to within a few centimeters, allowing them to optimize planting and harvesting. Ships can navigate precisely to save fuel and time, and pilots can rely on accurate positioning for safe takeoffs and landings. Plus, of course, you can share your location instantly with anyone you want. So if you're ever lost in the woods, you can call for help and search and rescue teams can find you quickly. Another advantage of GNSS is that it's available almost anywhere on Earth. Unlike traditional cell phone networks, GNSS doesn't rely on ground infrastructure. Signals can pass through clouds, buildings, trees, and other obstructions. And unlike older forms of navigation like maps and compasses, GNSS works day or night in any weather. Not to mention that anyone with a receiver can use it. No special permissions or equipment needed. Of course, GNSS isn't perfect. For one thing, if the sky is covered in clouds, or if there's too much atmospheric interference, your receiver might not get enough signals to accurately triangulate your location. Another problem is that GNSS signals can be blocked or jammed, either accidentally or intentionally. This can happen when a receiver is inside a tunnel or under a bridge or in a deep valley. Also, someone with malicious intent could try to fool a GNSS receiver by sending false signals, which is known as spoofing. But many apps and devices have safeguards against spoofing, such as requiring 2 separate signals from different constellations or measuring the strength of the signals. Finally, although GNSS is very accurate outdoors, it tends to be less accurate indoors because the satellite signals can be too weak to get an accurate fix. But remember those safeguards we just talked about. They're being applied increasingly to consumer devices, making GNSS better and more reliable than ever. What's more, emerging systems are supporting multiple GNSS constellations, For example, one company we've talked about before, Komatsu, combines GNSS with artificial intelligence and inertial measurement units to deliver highly accurate positioning and orientation data for everything from industrial equipment to self-driving cars. Their technology, called hybrid GNSS, can achieve centimeter-level accuracy in all environments and is immune to spoofing and jamming attacks. But what about the future of GNSS? What are scientists working on to make it even better? For one thing, quantum navigation. Just like quantum computers harness the strange rules of quantum mechanics to perform calculations that would take classical computers millions of years, quantum clocks can measure time with unprecedented accuracy. One quantum clock, called the hydrogen maser, which uses supercooled hydrogen atoms to keep time, can measure 1 second with an accuracy of 1 part in 10 to the 14th power. With this level of precision, GNSS receivers could measure distances down to the nanometer, which is about 1 million times thinner than a human hair. Scientists are also developing new ways to protect GNSS against jamming and spoofing. For example, one team from the University of Texas at Austin has proposed a system that uses machine learning to detect anomalies in GNSS signals and filter out the noise. Another approach involves sending encrypted GNSS signals that can only be decoded by authorized receivers. Finally, GNSS is being integrated with 5G and other high-speed communication networks to create what's known as the Internet of Moving Things, or IoT. This will allow billions of mobile devices to connect to the internet and share their location and other data in real time. Imagine a world where every car, truck, drone, and appliance is connected to a high-speed network and can communicate with each other to avoid accidents, optimize routes, and automate tasks. That's the promise of IoT, and it's only possible thanks to GNSS. Those are just some of the ways that GNSS is evolving and improving. As you can see, the potential applications are endless. GNSS is already one of the most powerful communication systems in the world. As it continues to evolve and improve, it will become even more indispensable. Speaking of indispensable, if you're looking for a way to learn more about the latest developments in science and technology, you don't have to look further than our channel. We cover everything from artificial intelligence to space exploration and everything in between. So if you're curious about the world and how it works, be sure to subscribe and never miss an episode. It's free and you can cancel at any time. Plus, we release new episodes every week, so there's always something fresh to watch. Don't wait. Start exploring today. Now back to the video. Let's summarize what we've learned. GNSS is one of the most powerful communication systems in the world. It's more powerful than any other system, full stop. GNSS is accurate, global, real-time, and cost-efficient. Those 4 little letters stand for Global Navigation Satellite. System in GNSS is more than just GPS. It's a constellation of satellites orbiting the Earth that transmit positioning signals anywhere on the planet. GNSS can be used to determine precise locations down to the billionths of a second, enabling all sorts of tracking, navigation, and surveying applications. GNSS is evolving and improving all the time. Scientists are working on ways to make it more accurate, secure, and reliable. And as it continues to evolve and improve, it will become even more indispensable. We've barely scratched the surface of what's possible with GNSS. If you want to learn more about this amazing technology, check out the links in the description. Thanks for watching, and see you next time.